Okay, we're going to go ahead and get started on Unit 2B-2, Graphing Rational Functions. We're going to start putting things together on this. So I'm going to run over some basic guidelines real quick on how we're going to go about doing this. And these are guidelines. There's no strict rule on some of this. Now, some of it we are going to require, but some you may find the additional steps helpful. First thing you do is simplify a factor if possible. Now, sometimes that's not always going to be the case. Sometimes you're going to have to do synthetic division or some other techniques to break down a cubic or quartic or whatever. You're going to identify vertical and horizontal asymptotes and the holes. Okay, these sometimes get forgotten, and I've been guilty of that too. You may catch me in class once or twice where I forget to graph my hole because we just don't pay much attention to them. But it is a discontinuity. We need to pay attention to those. We just got to watch out on our human natural tendency to forget little things like that. All right, and if possible, find the X and Y intercepts, and then we want to find and plot additional points, which is going to be fairly common at times because we want to try and get accuracy. Now, I did point down here that in my college classes, for the most part, I didn't do a whole lot of graphing. I got a full math degree without touching a calculator and doing very little graphing. It's a lot of algorithm work. But we don't know what kind of school you're going to go to. They may demand more precise things. I know my daughter, she's in the A&M system. She took PreCal just a couple of years ago, and it was an all no calculator class. And she had to do some very precise graphing on one particular test. All right, so you just don't know who you're going to get. Some teachers and schools and students do things like find the signs on each interval. Like, for instance, you have a few vertical asymptotes, and you find the signs on those intervals of doing plus, minus, or something like that. I don't know. This kind of takes care of it right here, to tell you the truth. And just make sure you're finding additional points. This can be a little deceptive because you may have one of those horizontal asymptotes that can cross, cross the asymptote a little bit. So be a little careful when you're doing that one. Let's go ahead and get on two examples. One's going to be a fairly basic example. You've seen this one before. And then one that's going to be pretty much more standard. All right, so this first one is basically the reciprocal shifted over left 2, if you remember your parent function. But let's go ahead and run through the steps. So the first step is I'm going to find my domain restrictions. Of course, we have x is equal to, can't equal to -2. All right. So I'm going to, well, I started in domain notation. You could do interval or set notation. I don't really care. And it's going to be -2, and then let's see, and then -2, and then union -2 infinity. Okay. Alrighty. So holes, we don't have any. We don't have that kind of dynamic going on. Oops. Let's draw that down there. We do have a vertical asymptote, of course, at x is equal to -2. I'm going to go ahead and graph that because I can't draw or diddly squat. I'm going to move this over here. All right, there's my asymptote for that. I have a horizontal asymptote. This is bigger than that, so we're going to have y is equal to 0. All right, I'm going to go ahead and drag that up. Y is equal to 0. Come on, you. Up you go. And there's my horizontal asymptote. X-intercept, not happening, so we don't have one. Y-intercept we do, and put a 0 in for that, we get a 1/2. 0 and 1/2. I'm going to go ahead and plot that point right there. Okay. So I probably want to pick a few other points because I remember my parent function. I know I'm down here and I know I'm over here. But if you forget, you probably want to pick a few points like -5 or -7. When you put that in there, you obviously get a small negative fraction. And when you start putting in like 5 over here, you're going to get a small positive fraction. So our end behavior is approaching y is equal to 0. This is going to be on the negative side of this graph, and this is going to be on the positive side. When it approaches in this direction toward my vertical asymptote, it's going to drop reciprocally. It's going to drop way down. Okay, it's going to get pretty darn close to very large negative numbers here, and it's going to go increasing over here. So what I have is, if I like put in -3, I'm going to have a -1 right here. So I'm going to come in pretty darn close, and it just slowly gets into there. and then I'm going to drop it and get really close to that. Okay, it's a limit basically. All right, so here if I were to do -1 in here, I'm going to get a 1, and it's going to be very similar. Okay, down it goes, and we're going to get very, oops, don't wobble, very, very close. All right, so that one's not too bad. Of course, we're not going to be giving you these on your test. We're going to give you something a little more interesting. Okay, so I call this an intermediate problem, and it's going to make you, we've got two quadratics that are very easily factorable. You just look at them and knock it out. You do need to make sure that you can factor reasonably quickly. Again, that's not a PreCal objective. We expect you to be proficient at it. But what times what is equal to -2 and gives you -1, so the bigger number gets the sign. And that's going to be 3 and -2, so x plus 3 and x minus 2. And of course the x minus 2's cross out, so I got x plus 1 over x plus 3. That gives me a hole at 2. So I have a hole at x is equal to 2. I'll go ahead and write that down. Okay, and I have a vertical asymptote of x is equal to -3. I'm going to go ahead and plot that. So I'm going to drag this one over at, not that, this over at -3 right here. Okay, there we go. And let's see what's going on with my horizontal. I got a 1 here and a 1 here, same degree, so my horizontal asymptote is going to be y is equal to 1. I'll go ahead and toss that up here. And there we go. Okay. I'm going to have a hole at 2, so I'm going to go ahead and plot that, maybe in a nice different color with a little bit of hole right here. But I'm going to probably want to put that into the thing. Where does that 2 fall into? Well, if I put a 2 in there, that's going to be 3, and that's going to be 5. 2/3. It's going to be somewhere right around in here. Okay, it's going to be somewhere right around there. All right. I'm not going to be too concerned about it. But I got to remember, there is a hole over there. If we're not exactly precise, I'm not going to lose sleep. X-intercepts, we got one. All right, I can simply put that equal to 0, and I'm going to get x is equal to -1, so I'm going to have -1 and a 0. So I'm going to go ahead and plot that. There's an x-intercept. And I have a y-intercept. When I put those 0, I'm going to get 1/3. So 0, 1/3. I'm going to go ahead and plot that right about there. So it looks like something's coming up like this. And if I do it a t-chart, I'll do one real quick. And I started throwing in some points just because I'm a little paranoid. I want to get max points possible. I'm going to do things like, oh, let's see what -4 is doing. All right, it's real close to this asymptote. It's just 1 over. So I just kind of plug it in. I could plug it in my original function. I could plug it in over here. And I see that, okay, that's going to turn out to be a 3. All right, so -4, 3. All righty, got an idea of what's going on here. -2, let's try the other side. Let's put it right here. Well, -2, oops, I get a -2, and I get a -2. That's going to be a negative. It's going to be a -1 right there. So I have -2, -1. So, okay, I can see that happening. That's predictable. All right, so I kind of feeling pretty comfortable with this section over here. Over here, not so much just yet. I think, well, I'll do one more. I'll do 1, I get 0.5. Well, that was my hole right there. So my hole's at 0.5. And I better do a couple of negatives. So I'm going to do -5, and I get a 2. And I do -7, and that's going to give me 6 over 4. That's going to be 1.5. All right. And again, my hole being at, why is my dog barking? Well, anyway, I'm not going to worry about the dog. I'm going to go ahead and sketch this out. So here I am coming like this. I better worry about the dog. Somebody's here. Probably my realtor. Going up. We're selling my house. My beautiful, beautiful house with a great backyard where bobcats chase roadrunners. Coming up like this. And boom. All right, there we have it. I'm going to show you one more thing. Yep, I got a guest here. Yay. So what I have here is a more interesting example. Sometimes we give these to you in factored form. You can see the multiplicities of the x plus 1 and the x plus 3 are both 2. Well, that may mean some kind of tangent relationship. It may not, and because we have a lot of dynamics going on. So what we really have is a vertical asymptote. So what you would do is, okay, I can handle this. Let's go ahead and find all my asymptotes or my domain restrictions. Well, we know we have a vertical asymptote at -3. There's no holes here. So -3 and a +2. So here's a -3 and here's a +2. And let's go ahead and sketch those. We also know that we have a cubic here and a cubic here. And with leading coefficients of 1, that means my horizontal asymptote is going to be 1. So we go ahead and graph that out. We can knock out these X and Y intercepts. Now that takes a little bit of work. The Y-intercept's a little bit easier than the X-intercept. But we can still knock them out and come up with our 2 intercepts. Then I would probably do a few, well, we got that one over there too, because we put that X is equal to 3, X is equal to -1. So we got 2 X-intercepts. So the reason is that we want to be a little careful and maybe plot a couple of points, because look what happens here. We've been conditioned in Algebra 1 to just something that looks like a nice symmetric quadratic. That's not necessarily going to be the case. This is not symmetrical with this going on right here. So you probably want to do a few more test points in here. You probably a couple of test points right around in here, and maybe one over there. And a test point maybe right around in here. Maybe, well, 3 is going to be pretty close. Maybe one over here. See how fast it gets to that horizontal asymptote. You knock those out. But this is something more than you can expect. I mean, this is pretty much what you can expect for the course. Alrighty, I'm going to go ahead and get this posted and go see if my house is sold. All right, bye.